All right, there we go. All right, so basic Python. So when you're programming, you obviously want to declare variables. Um, in Python, you don't have to specify what type your variable is going to be. You just type in the name of your variable, set it equal to the type of the data type that you want to set it to. Integers, booleans, floats, whatever you want. Just don't do some weird stuff like putting a number in front of your variable name.
And just quickly, for the sake of the recording, so people watching this later know what it's all about. Today is Intro to ML. We're going to be going over basic Python that you will need for machine learning workshops that we'll have later on in the semester, as well as essential libraries such as NumPy and Pandas. So yeah, I'm sorry, DK.
Yeah,
Continue.
no, yeah, good point.
You guys should post the link again because if people who are watching the recording also see the Zoom chat, so then like they can also open the stuff.
Yeah, this will be on YouTube and we'll post it in the description as
Oh,
well.
cool.
Yeah. But thank
All right. There's different types of numbers that you can use: integers, floats, obviously whole numbers or integers. If you want negative numbers, just put a minus in front of it, you get a negative number. Floats they're all decimal points. Just represent it like how you would in a decimal point. Sure, it's the same for other languages. Arithmetic operators, addition, subtraction, division, mod, multiplication, power of. So yeah, anytime, here's some examples of just going through the different operators. Let's see. Anyone have questions? If you have any questions, just post in the chat or just unmute yourself. Feel free to interrupt. Let's see, booleans. There's just two types, true and false, and you get boolean returned when you use relation operators, like equal equals. You have two variables are equal to each other, not equal to, less than, greater than, less than or equal to, greater than and equal to. Yeah, pretty simple stuff here. And then there are strings. Say you set a equal to string a, and then a has a type of string. You see this is not a type integer because it has quotes around it. So if you run this cell, it returns class type of string. That's anytime you were curious about or forget what a variable type is, you can just print out type of the variable at any time. Lists are probably the most commonly used data structure in Python. They are separated by indexes. So here, you declare a variable or declare a variable name A, creating an empty list. You see that the type variable A is type list. And here we're going to create a list X and a list Y, and they hold different values. Let's run that cell. So indexing always starts from 0. So if you wanted to get the index of list X, you would say X column or bracket 0 bracket, and then let's see, it should return A, which it does. And going back to the operators, let's see if the data types in list X and Y are the same, which they are because at index 1, which is here, which is B, and index 1 here is B, so it should return true. Next, we have if-else statements. So how it works is if a certain condition is true, you execute the code in the first block of the code. Else, if it doesn't execute the above code, you execute the code below. So since this is true, as we saw above here, this should print, which it does. Now let's create 2 new lists here, X and Y. And so if Y variable at index 2 and for list X, this will not print because at Y index 2, there's 5, and X at 0, there's 1. Let's test. So because this if statement wasn't true, it didn't execute this block of code. It just, because it's an else, it automatically executes this block of code right here. You can have as many if statements as you want. So you can just have as many as you want. And then there's a different type of if and else where it's if and else if. So the different thing about that is if you have a bunch of ifs, if all the ifs are true, it'll keep executing the blocks of code. But if you have else if, let's say A is 20, if A is less than 20, no, then you move on to the else if. Is A less than 20, then you go into the blocks of code. You execute this block of code, but you, because it's an else if, you never check this next else if. It executes this block of code and just breaks out of the list of else ifs that you've typed out. So there's that. But just to make it a little clear, let me see if I can do this. So like what I was saying is, if this was all ifs, you execute this, you get both blocks of these codes are executed rather than just the one using else ifs. Next, we have while loops. So while relational operator is true, you always execute the block of code what's inside that while loop. So first we set I equal to 1. So we say, is I less than 5, which is true. So we execute this print statement and increment I by 1. So now I is 2. Is 2 less than 5, which is true. So we keep executing the block of code. So that's why we get these print statements. So while I got to 4, I got incremented by 1. Now it's not 5 is not less than 5. That's why you break out the while loop. Next, we have for loops. So for I in something like an iterator, you execute the block of code. So for I in range of 5, so anytime you do range number, so I starts off at 0 and it increments by 1 and goes all the way up to 5. There are, and then you can also do with 2D lists. So where for L in list 2D, it's not going to be going over the specific numbers that are 2D. It's going to be returning the actual list by list. And then, but if you wanted to print the exact numbers within the list, then you put another for loop saying, because L is the list, and then you say for number in the list, then you get the specific numbers within the list, within the to-do list. And finally, list comprehensions. So anytime you want to create a new list and don't want to type these 4 lines of code, you can just do it in 1 line. So this is the general syntax. Name of the new list that you are trying to create, the item that you're going to add to the list. And so for item in iterable like a list, if the condition is true, then the item will get added. So here, this is the list comprehension version of this. We're trying to create a new list, and for I in range 10, we're appending the I to the list that we created, and this should return from 0 to 100 or 0 to 90, I guess. And let's see if we did the list comprehension the right way. You did, because as I mentioned, so for item in iterable, which is this right here, we put it where we want it, and the item to add is right here. We're multiplying I by 10, but down below it's X, but same thing. You multiply by 10 and you add it to the list. And then in this example, let's add a condition. So for X in range from 0 to 20, if the X is less than 10, then it only gets added to the list. And while it's being added to the list, you will multiply it by 10. And this should give us the same list as the above. Any questions? Anything? I can't really read chat or anything.
Yeah, so we're going to be moving on from Python after this. And this is, I
Yeah.
know, basically just pseudocode, but if you have any questions, feel free to ask.
Yeah. All right, and then that's it for Python. Sam will be going into a little more exciting stuff with NumPy and Pandas. So
Yeah.
if you want to take over, Sam, go ahead.
Yes, I will. Excuse the tabs I have open. But yeah, let's get started. So now we're on to the spicy stuff. This is the foundation for any kind of data science in Python. It doesn't even have to be machine learning, any kind of data processing. So if you have any questions about why NumPy and Pandas are useful, please ask me. But for now, I'll just go into NumPy first and then Pandas. So what NumPy is essentially it just provides a way to perform, I guess, vector calculations in Python in a much faster way than just base Python. So that's what we'll be showcasing now. This notebook was not authored by Google. Well, we authored it and we're Google, so that's okay. All right. So here we just imported NumPy as NP, Pandas as PD. I'm gonna guess a lot of you have had at least some experience in Python, so that is pretty self-explanatory. If not, just ask any questions. Not in chat because I can't see chat. Okay, here. So the basic building block of NumPy is the NumPy array. This is different from the Python lists that you saw earlier over here. These are specific, they're their own type of data type. This is a NumPy array. As you can see here, you declare a NumPy array, or one way to declare a NumPy array is just by passing in a Python list into np.array, and then you get the equivalent in NumPy. And here, NumPy provides many different functions to automatically fill and generate NumPy arrays for you. So for example, here, y, np.ones creates a NumPy array whose contents are all the number 1, floating point 1. And what this parameter is right here is 2 comma 2. So that parameter is a tuple specifying the shape of the NumPy array that we want to create in row major order, which I think is something we learned in 103, CS 103, if y'all have taken that. So 2 specifies the number of rows we want in our matrix or NumPy array, and the second number 2 here specifies the number of columns we want. So as you can see, it is 2 by 2. Yeah, I'm not going to highlight the columns. Very cool. So it's simple to create matrices like that in any shape that you want. Here we see another example. Instead of np.1s, you can generate a NumPy matrix with zeros, and you can specify any shape you want, any shape of matrix you want. So here we just did 2 by 2 by 2, and you can see that right here. And feel free to ask any questions that you have along the way. Another very useful way you can create NumPy arrays is by using an np.arange, which just creates a NumPy array from 0 to whatever number you pass in to the arange function. And you can pass in other parameters like step or increment size. So if you say you want the numbers to increment by 2, or you want them to start from like 5 instead of 0, you can do that as well. Another big part of NumPy, and something that will become very important in machine learning, is reshaping arrays into sizes that you want. So here, as you can see, we created the NumPy array W, and it's a one-dimensional array, just has 20 elements in it, 0 through 19, right? But say we, for some reason, want to reshape this matrix into a 4 by 5 matrix, 4 rows, 5 columns. We can do that just by saying w.reshape and then passing in the desired shape that we want in the form of a tuple. And you can, as you can see here, we have our 4 by 5 matrix. So that is very easy. You can check on the properties of arrays by various attributes from NumPy arrays. So for example, here you can verify that W is indeed 4 by 5 by doing w.shape. You can confirm that we are actually storing integers within W by doing w.dtype. As you can see, we have an int. So yeah, that's very cool. That's some very basic NumPy. Now we'll get into some operations you can do with NumPy. First, we're going to generate.
I'm sorry, real quick. Hello?
Yes, hello.
Can you do a really quick refresher on what the difference between a tuple and an array is?
Sure. Let's see if I can add something here. Okay, so a tuple, so a Python list. So you say array, but I'm just going to use the word term list. Python list is just something like this. Your classic array you can think of, it's just like the first data structure that everyone learns, right? So that's a list. A tuple, on the other hand, can be, I guess, n-dimensional, however much you want. But a tuple is of the form, has the syntax parentheses, and then it's just separated by commas here. So the only syntactical difference is whether it's enclosed by brackets or parentheses. And they're just different ways for representing data. Like for example, I mean, this is kind of out of scope, but say I want to define a Python function, right? I could, so say garbage function wants to return A, then it would return a list. But what if instead I returned this, which is the same information instead in tuple form? Then what I could do after running garbage is I can, so other languages you might have had experience with, like Java, for example, can only really return one element from a function, right? However, in Python, you can return n elements from a function by putting them into a tuple when you return them. So for example, this you could just this would return 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could just capture that in B, C, D, E, F, G, H, I didn't bother counting, so pretend that's 10 letters.
Yeah.
And then like B would then hold 1, C would then hold 2, stuff like that. And so
This wouldn't work if we're returning an array.
yeah,
So structurally, arrays and tuples are pretty much the same, but they just have different, like when they got return or when they got read in, then it's different. Is that the only difference?
I mean, I think
also I believe lists are mutable, tuples aren't.
Oh.
Yeah, so if you set a tuple, like Sam has, let's say like A were to equal to the tuple that Sam has created, I'm pretty sure you can't change the values in that tuple once it's set. I'm pretty sure you can't do that.
So you can't change values inside of
in tuples. In lists you can. Yeah.
Okay, thank you.
And as you can see here, like B, C, D, whatever, we have appropriate that. So yeah.
Okay. Yeah.
Hopefully
Okay,
that.
thank you.
Cool. You're welcome. All right. Let's move on with NumPy. So NumPy, because it is very data sciencey, it allows you to also generate NumPy arrays and matrices with values sampled from a normal like Gaussian distribution. And you can specify the size there. And you can also specify via additional parameters that I didn't include here for simplicity, the mean and the, I guess, scale of the sampling space. So you can do that here. And here you can see we generated 2 distinct 4x4 matrices with values that were sampled from a normal distribution. So I'll just run that again. And as you can see, the numbers change because it is random sampling. All right. So what are some operations that we can do on NumPy arrays? Well, if they're both the same size, and even if they're not the same size, but I'll talk about that later. But for now, assuming you have 2 matrices of the same size, you can add them together. And you might not be able to tell because these numbers are kind of complex, but it does element-wise. So this element is added to this element is added to this element, and so on and so forth. And that should make a lot of sense. Same thing with multiplication. You can multiply element-wise. You can do the dot product if the matrices you're dotting together have the appropriate dimensions, compatible dimensions. That's just basic matrix operations. You can do element-wise operations by just specifying a scalar value. And this is a form of what's known as broadcasting. I'll talk about it a little bit later, but just keep that term in mind. What NumPy essentially does is it takes this number 1, and even though it's just one number, it broadcasts that one number to every single element in the matrix. And as you can see, well, I think I should probably actually run all of these. Oh, I did. Okay, and then as you can see, it subtracts. Did it subtract 1? Yes, I'm going to say it subtracted 1. It subtracted 1. Yeah, it subtracted 1 from A, if you check up with A earlier. You can also do the same thing with scalar multiplication. And you can also perform, I guess, condition checks on the values within your NumPy array and generate a list that way. So as you can see here, we have the condition check. Whether each individual element in A is greater than 0. And as we run, you can see that if the element in A in this position was greater than 0, it spits out a true. If it was equal to or less than 0, it spits out a false, so on and so forth. So those are some basic operations.
Sam, we have a question in the chat. Is A times B matrix multiplication or element by element multiplication?
It is elements by elements multiplication. To do dot product, which I guess is matrix multiplication, you would use this syntax, A dot B or A at B. Both work exactly the same way. And if the dimensions of the matrix are incompatible, you'll just get an error. And NumPy will let you know to fix that. Okay.
Earlier when you created the matrices, what was the normal function? There was like a dot normal.
Here?
Yeah.
So you're just here. You're sampling numbers from a normal distribution. Do people know what a normal distribution is? If not, don't worry about it. You'll learn that in Math 407, I think, which I am taking right now.
Okay.
Yeah, but if it's just a common thing in statistics. You'll hear it a lot as you continue your CS journey.
Okay.
Yeah. Also, it's a quick Google search would give you a lot of helpful info. But yeah, cool. Any other questions about NumPy?
I just have a general question. What's like the importance of these matrices in machine learning?
Sure. Okay, so just first overall, just like generally NumPy is much faster than Python operations. So if you want to do any sort of matrix operations, then you're much better off using NumPy than just base Python. But as for applications to machine learning involves a lot of linear algebra, involves a lot of, so we'll get into this in the next workshop. So I don't want to jump ahead too much and confuse people, but like neural networks and like weights multiplying against parameters into a neural network, that all involves a lot of matrix operations that you can carry out with NumPy. And so NumPy is very useful in that respect. Although there are like frameworks and libraries that take care of those calculations for you now, it's still useful to implement maybe once or twice in your life a neural network from scratch to really understand how things work, and you can use NumPy for that. More practically, I guess I'll just give an example from when I've used machine learning and NumPy together. I'm sure DK has examples as well. And feel free to jump in. But last semester, I was working on a project with some people investigating whether like natural language processing reviews of resumes was biased towards certain genders or not. And there are these things in natural language processing called word embeddings. I won't get into too much what that means right now, but essentially just like bare bones, what that means is you can extract a numerical representation of how closely different words are related to each other. And we put that information in the form of NumPy arrays. That was a natural way to look at that information. And from the numbers in these NumPy arrays and from the operations we conducted on them, we were able to see whether maybe like female gendered words were less associated with software developer, whereas male gendered words were more associated with software developer and things like that to reveal bias. So that's one way you can use it. It's a very versatile. DK, do you have any other examples?
For me, particular for pandas, I have to clean a lot of data sets while doing machine learning. So it's pretty simple to do if you have thousands of rows of data, but if you're thinking about millions of rows, it's very convenient to use a library like pandas. Yeah, this is the direct example I had.
Cool. Speaking of pandas, we'll get to that next. But first, did that answer your question?
Yes, it did. Thank you.
No problem. Any other questions about NumPy? Great. Okay. Guess I did a fantastic job. All right. Water break. 1 sec. Okay. Now we're on to pandas. Pandas, general overview. You can think of it like kind of an Excel spreadsheet almost within pandas, and you can, within Python, and you can do many different sort of things with it. You can also just think of it as like a fancy table diagram within Python. But let's get into it so you can see more concretely what I mean. It's used for data manipulation, as DK said. So first, the basic unit within pandas is called the pandas data frame. And the data frame is where you put in all the data you want to look at. Machine learning involves a lot of data processing, and maybe even most of machine learning is data processing in some respect. So pandas provides an easy way to store and access and manipulate your data. And how you do that is by putting said data into a data frame. So here, we have just created a new pandas data frame called df. And remember, we imported pandas earlier as PD. So that's what we're doing. It's essentially just pandas.series. And what this means, here in the data parameter, we're specifying what data we want to put into our table of data. And like before, as I demonstrated earlier, you can create a NumPy array with random values. Here we create a NumPy array of 5 values. And then we pass this NumPy array as the data parameter into this pandas series constructor. And pandas is smart enough to know to take this NumPy array and turn it into a pandas data frame. And as you can see here, I'm just, that's quick syntax in Colab to display what an object looks like. So here I'm displaying basically what the pandas data frame looks like. And here you can see the 5 individual elements within the NumPy array that we passed in. And they're indexed 0, 1, 2, 3, and 4. And they're of the float data type, which is what we expect. It might not be immediately apparent to you why this is useful, because this kind of just looks like a list, but it'll become clearer later. And as you can see here, some of the syntax is similar to the syntax of accessing Python lists or just arrays in general. You can access the third item within the pandas data frame by just this square bracket syntax, which hopefully everyone knows. Here, we're creating another pandas data frame, but here, instead of indexing by numbers 0 through 4, which is what you saw in the previous data frame that we constructed, we can also specify an index that we want. And say for some reason we want to specify by letters, because that just makes sense for the data set that we have. And we can do that. So we specify that here. And you can see that now, instead of numbers 0 through 4, we have letters A, B, C, D, E. And now, as before, we can access not only by number now, we can access items within our data frame by the index that we have specified. So we can access C. And as you can see here, we access the second item in the data, 0 index. So technically the third item in the data frame, and that's the same as index C. So that all corresponds and makes sense. And feel free to.
Got a question. What's the difference between Panda series and Panda data frame? Do series behave more like an array?
Okay, so Panda series, maybe this will pop something up that will help explain. Yeah, so I don't think it did actually. Well, okay. So Panda series is just, it's essentially, I guess you can think of it as a constructor. It just constructs a data frame. They're not separate. A series is just a way you can, it's just a method you can use to construct a data frame. All series does is take in what you give it and then return a pandas data frame. They're not really separate in that sense, if that makes sense. It's like a constructor. Cool. There's nothing else. I will continue. So that was one way you could create a data frame using series. But here is another way you can create a data frame. Here we are specifying explicitly what our entire structure of our pandas data frame. And if you notice earlier, all of our previous pandas data frames only had one column of data values. Here in pandas, in this pandas data frame, we're specifying 2 columns of data values. So let's do that really quickly. And as you can see, as you essentially just pass in a Python dictionary of the form of with the structure of information that you want to be stored inside your pandas data frame. So let's just break this down really quickly in case you don't know what pandas, I mean a Python dictionary is. So here we have key value pairs in our dictionary that we've passed into this data frame constructor. The key here is column 1, and inside column 1, we want this column to have the floating values 1, 2, 3, 4, 5. And then we also want to create another column. So we specify a key, column 2, and then the value associated with that key is just a list of strings that we want in that column. So blue, gray, lime, red, orange. And then if we just show the data frame here, we can see we get exactly that. We get a column 1, one column named column 1 because we specified the name here with values 1 through 5, and another column, column 2 with the name we specified with the colors that we specified. And this also goes to show you that it's not just for storing numbers. You can store strings and lists and stuff within pandas data frames as well. So this also introduces a new way you can access information from the data frame. So previously we were accessing by either like these index numbers on the side or by the index values that we introduced earlier, that we specified specifically, such as A, B, C, D, and E from our previous example. Here, since we added column names, we can access information by column name. So here, the square bracket syntax, same as you guys are probably familiar with. We just access all the information within column 1, and you can see that there. That's pretty straightforward. So there's another way to print rows. This is another way to access information. This is just the syntax, just dataframe.lock for location, and then you just pass in within square brackets. This is very important to remember this syntax. Get the right number of square brackets. 0 stands for row 1, and you just get all the information in row 1. If you just want to row 0, technically. If you want to get row 1, you can just pass in row 1, and you can see it matches there. If you want to get info from row 2, you just pass in 2, you get info from there, and so on and so forth. That's pretty straightforward. All right. So there, like in NumPy, you can also perform operations inside a pandas data frame, which can be useful sometimes. So here we already have a pandas data frame called df. And here we're creating a new column inside this data frame called column 3. And what are we going to put in that column? Well, we're just going to multiply the values of column 1 with itself. Essentially, we're just squaring all the values in column 1 and putting them in column 3. And with the exact same syntax that we saw earlier, just accessing by column name. If we do that, you can see that column 1 is here. 1 squared is 1, 2 squared is 4, 3 squared is 9, and that all makes sense. Yeah. And this DK, do you remember if there's broadcasting in pandas? All the columns have to be the same length, right? I think you're muted.
Oh, okay. Yeah, they do have to be the same length, but some like columns can hold none values, like NaN. Yeah.
Yeah. Okay. So, thank you.
We have a question real quick. Can we create row data instead of column with data frames? I think they're saying, can we insert rows of data instead of new columns into a data frame?
I'm going to say yes, because I think I remember.
Yeah, you can.
But I forget the syntax off the top of my head. DK, do you know?
Not off the top of my head, but I'll find it for you, Brandon, and let you know.
Okay. That's how dedicated we are. We will Google things on the side for people. Yes. Okay, so we just finished that. Now we're here. This is just another way you can insert information into your pandas data frame. So say we have a column called UCLA, and we want to enter some information that is closely affiliated to or related to UCLA as an organization and as a campus. So obviously we all know UCLA equal bad. So here we can just specify we want to create a new column with the column name UCLA, and all we have to do is specify a string. And what pandas will do for us is just, I guess you can call it broadcast this string all the way down to fill the necessary number of rows into the data frame to match the rest of the fields of information. And you can see that here. Even though we only specified a single string, we didn't put in a list or anything, pandas knew to just populate that entire column with the right number of bad strings. And this is just one last example of pretty much doing the same thing. We have a column for UCLA greater than USC, and we want to populate that with values associated with that column name, because you want to name column names and with something descriptive that will tell you something about the information in that column. So here we're storing information about whether or not UCLA is better than USC, and we just have a condition here that returns false. And again, Pandas is smart enough to know to populate that entire column with the right number of falses. Yeah, so there's that. Also, quick tip, we probably should have mentioned this earlier, but if you're following along live and you want to run one of these code cells, you don't have to press the start button every time. If you press shift and enter at the same time, or first shift then enter, then it will run the cell that your mouse is in. So apologies for not mentioning that earlier. Any questions at this point? Fantastic. So moving on. So these were just some toy examples with like just 5 values in the data frame, which you would almost never have if you're working on a real project. You'd have a lot more than that, a couple thousand or even more than that. So here we're just going to be working with some larger examples now. And when we had only 5 items or 5 rows inside our data frame, it's pretty easy just to view the entire data frame. But then the question becomes, how do we view a pandas data frame with like thousands of columns? And that's what we're going to be exploring here. So here we're creating a large data frame, very appropriately named, with this constructor that we went over earlier. And we're using that same key value dictionary syntax to specify what we want inside our data frame. So here we're just specifying the name of the column as the key. And here we're passing in a NumPy array of random values, of 1,000 random values. And that's what's happening the same for column 2. So column 1 and column 2, we're passing in 2 separate random NumPy values. And if we print out what this large data frame looks like, as you can see here, Python it's not going to show you all 1,000 rows because that would take up way too much space, right? It would show you the first 5 and the last 5. So that's how that works in large data frames. Now, say you just want to look at the first 5 or the top of the data frame, you just do dataframe.head, as you can see here. If you want to look at the last 5, you do dataframe.tail, do that. And that's essentially how you can take quick glances at what the data inside your data frame looks like without having your entire screen just like filled up with like thousands upon thousands of rows, and you have to scroll down forever. But yeah, so that's how you view the front and back of your data frame. Now, say for some reason you screwed up pretty bad, and you want to, or maybe not even screw up, this is just a natural evolution of your project. You want to flip the orientation of your data frame. So remember earlier we had column 1 and column 2 as the column names, and we had the indexes 0 through 999 as our row index values. What pandas allows us to do is to transpose a data frame. So what that means is our columns become our rows essentially, and our rows become our columns. And if you take the time to compare values, you'll see that yes, like the values match up and logically where they would be if everything was flipped. So yeah, I won't go too much into how this works, but just know that you can do that if you want. You can also sometimes with these large volumes of data, it'd be helpful to sort this data somehow to help you make sense of it. You can sort by several different things. And here we're sorting our large data frame that we specified earlier by the values in column 1. And by default, it goes from lowest value to highest value. So if we do that, you can see that, yes, the first item that it now shows within the data frame has the lowest value for column 1. And then the next item has the second lowest value in column 1, and so on and so forth. Note that it did not sort column 2. It's only sorting based off of the values in column 1, since we specified that here. And you could sort by column 2 if you wanted. Just change that just to show you. And see, now it's sorted from least to greatest order in column 2. So you can do that. Cool. Any questions before we go on to, wow, running out of time. Great, I'll speed through this, but any questions? Great. Okay, so now we'll get into a little bit of a practical example. So ignore the syntax. That's just some special Google Colab command to download something from Google Drive into this notebook so we can access the file that we downloaded. So let me do that real quickly. It might take a little bit, or maybe not. It didn't take very much time at all. And so before this workshop, I put a CSV file with some soccer data into my Google Drive. And essentially what I've done here is just download that CSV file from my Google Drive into this notebook so that we can use it. And in case you're curious, on the very left of the screen here, you can press this file icon and it'll show you all the files within that are loaded into this Colab notebook. And as you can see here, our soccer data.csv file has been successfully loaded because I ran this command. So that's done. All right, so here is some examples of how a real life pandas data frame might look. So as I mentioned previously, pandas data frames, you can kind of think of them as Excel spreadsheets. And as some of you may know, you can open CSV files, and CSV stands for comma separated values, in case you don't know. And you can open CSV files directly into Excel. And that is essentially what you can do with pandas as well. If you have a large amount of information stored within a CSV file, you can just use pandas' helpful built-in read CSV function, and it will automatically generate a pandas data frame based on the information within the CSV file, if it's all properly formatted within the CSV file. So if you run that, you see all this information now populated within a pandas data frame. So here you can see various information that was in the pandas in the CSV file now inside the pandas data frame. You can see player ID, and just a disclaimer: this information is from the FIFA video game. So apologies if you have not played that game before. This might not make very much sense, but this is just information about individual soccer players within the FIFA video game. So here, as you can see player names. There's Lionel Messi, greatest player of all time. The age of the player at the time when the game was released, a photo of that player, their country of origin, the flag of that country, their overall rating within the game for just like game purposes, their value in terms of how much value they're worth to a club, and so on and so forth. And you can see it goes on and on and on and on. And hopefully this illustrates the fact that data frames can be very large and pretty complex. And data frames allow you to, I guess, view them in a useful way and perform operations and access data in a useful way within Python. So sort of combining everything that we learned previously, hopefully you guys paid attention during list comprehension. We are going to hear, oops, pretend you didn't see that. Access some information from this pandas data frame. So here we're using list comprehension to create a Python list called best players. And we're using list comprehension to access this data frame and populate it with specific data that we want. So hopefully you didn't read that comment that I just deleted. Does anyone want to take a guess as to what this does? Note also that I can't tell how many participants are in here. So if you all left already, that's okay. Oh, 15, that's not bad. All right. Anyone want to venture a guess as to what that does?
Someone asked, what is enumerate function?
Oh, yes, enumerate. What it essentially does, so as you can see here, your basic for loop syntax, for blank in blank. But what enumerate does is, so in a traditional for loop, all right, another Python lesson, for a in 1, 2, 3, 4, 4, 5. In a traditional Python loop, a here would just stand for an element inside whatever we're iterating through. So in this case, it'd be 1, then it would be 2, 3, 4, 5, 6. But notice, unlike other languages, here we don't have any kind of notion as to index within an array or index within something we're iterating over. And what if we want the index of whatever we're iterating over? And that's what enumerate does. So you can wrap whatever you're iterating over within the enumerate function. And what that will do is, along with iterating over the individual items within the iterable, now you will also have access to the index of that item. So then let's see what this looks like. As you can see here, index now corresponds to the index of whatever A is. So in the first iteration of this for loop, A would be 1, right? And then index would be 0 because you're iterating at this iteration, you're at the first index within the Python list. So that's essentially what this does. This will return like 0 through whatever, however many indexes there are. And this will return actual items within whatever we're iterating through. Yes, that probably should have been explained. If anyone still wants to take a guess, please do, but I'm just gonna, I guess, tell you what it is now since we're kind of running out of time.
There's another question. Does the best players array get the names of the players from the Everton club? I guess that's the question. Guess a guess to the answer.
Yes, exactly. That's exactly what it does. Good job. I don't have any prize for you, unfortunately, but knowledge is its own reward, I guess. Not really, but yeah, so let's just break this down for people who might not understand. So syntax here is basic list comprehension. It's pretty simple if you just take the time to break it down piece by piece. So X is what we're putting in our array. And here we're doing for index comma X in enumerate soccer data frame, column name. So what does that mean? So we're iterating through the name column in this pandas data frame because we've accessed the name column. And because we wrap this in enumerate, we also have access to the index of all the names that we're iterating through. So for example, Lionel Messi would be 0 and X would be Lionel Messi, and so on and so forth. But here we introduce a condition. We only want to include X inside our best players array if at the index within the data frame that the player we're considering is at that index, whether the club at that player's index is equal to Everton. So essentially for 0, for Lionel Messi, we're going to be checking at index 0 whether or not their club, the string inside the club column is equal to Everton or not. And obviously it's not equal to Everton, so we don't include Lionel Messi. And we just iterate through the entire pandas data frame like this, comparing clubs to Everton and including them players inside our best players list if they match. Yeah. That is it. Any questions?
Not in the chat. Very good.
Great. Well, in that case, anything you want to say, DK, about what we are?
Someone asked, where are the cats in your browser from?
Oh, that is actually the most important question. That's the best question I can ask. So go to Tools, go to Settings and Collab, and then go to Miscellaneous, and you can turn on Corgi mode as well as Kitty mode. So if you turn on Corgi mode, you'll see cute little corgis pop up. There's also this thing called power level, which is kind of jokes. Let's see if it shows up here. You see, the power level is too high, my screen froze. But so I guess be warned if you use that. But those are just for fun. They won't like access like or affect your collab experience in any way. Power level is honestly kind of annoying, but you do you, I guess. Yeah, so that's how you get corgis and all that cool stuff. Yeah. If there's one thing I want you to take away from this workshop is just how to get corgis on your screen. It's the most important thing to ML. Cool. Any other questions before we start talking about what's next? Great. In that case, DK, you want to mention what we have planned?
Well, now that we know the basics of NumPy and pandas, we can move on to TensorFlow. So next workshop, which will be next month, we're hoping to introduce you guys to TensorFlow and tackle on the project Hot Dog versus Not Hot Dog from Silicon Valley, if you've watched that show.
Yeah.
Everyone, yeah.
I guess we'll talk about the Yin Yang certificate next time.
Yeah.
It requires some explanation, but yeah. So essentially, next time, hopefully, we're going to be putting all this information that we've just learned into use by implementing a basic machine learning project using TensorFlow. And TensorFlow, in case you don't know, is one of the most popular machine learning frameworks out there that people in industry use. Research uses, although research tends to use PyTorch a little bit more. But a lot of people use it, and it's a great skill to learn. It's essential, actually. So hope to see you there. Anything else?
Not on my end.
Okay. Maybe you stop the recording then.
Yeah.
This